Hello, 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 everybody, and welcome back. We're looking at question 13 now on the 2008 Cayley contest. The diagram shows a piece of cardboard that can be folded to make a cube. Oh goody, it's a two-dimensional net and a three-dimensional problem. Fantastic. I know a lot of people out there are in the same boat as me. Three-dimensional geometry questions, not your strong suit. That's okay. Let's see what else this question's talking about. The cardboard has designs on one side only. Which of the following cubes can be made from this cardboard? Okay. So the question is, how does this net fold together? And you'll notice that some of these shapes are quite particular. Like for A. Sure, we might recognize that around the same corner we have the blank, the X, and the, let's say, smiley face, or the U. But do they actually come together this way? Okay, and so this question is it can be a little challenging. One thing that I have recommended in the past is that you, depending on your proctor, you can actually bring some blank wooden cubes or some wooden geometric shapes. These sorts of things can be picked up from I want to just sort of a craft store like Michael's or something like that. And it can be quite helpful, especially if you had a wooden one. You can just get a pen and sort of, what do I want to say? You can just sort of draw these shapes on here. Now, to do that, you would have to sort of go from the net that we've got in the picture, this net here, and be able to accurately translate that to a three-dimensional cube. But then you could rotate it around various sides and say, hey, have I got C? Have I got E? Okay, only one of them will be correct. So I'm going to try and not do that. And of course, if you don't have wooden blocks, sometimes people don't let them in, you can just sort of rip up some paper and try and fold that into a net. It won't be super exact, but it's still something you can try and do. Or even if you just, some people I know who are really bad at cube problems will do this. They'll bring in something like a Rubik's Cube, because, smart people have Rubik's Cubes, obviously. And, they'll play with it ahead of time, and then the proctor will say, okay, put things away. And they just sort of put it up, but then they have that nice little visual thing. You don't even pick it up and handle it. You might get accused of cheating with something like that. But just to be able to say, okay, I think I'm going to make the red side the X and that sort of stuff. Even something like that can sort of help you in your mind. Not always, but certainly something worth trying. Okay, but let's suppose we don't actually have any three-dimensional aids and we don't want to rip up scrap paper. How might we approach this question? Okay, so let's focus on the net. I'm going to copy the net down here. Doesn't have to be super exact, but there we go. 4 across, and we've got a pair 2 here. So X, we have a U. I believe the V is like this. Is that my dot? I feel like, yeah, that's my dot. So, and then shaded here, and then the rectangle is slanted this way. Okay. So, they're showing us these cubes. I want to say the pictures they're giving us are sort of isometric. Now, one thing you can do if you're good at spatial reasoning is you could sort of fold this together in your mind and draw a little picture. Problem is, they're not all presenting the same thing. Like, it's not always the X side that they're presenting to us or something like that. So what I would do for this question is I would say, all right, let's take a look at A, which is X. I think the smiley face looks like that, and it's blank. Oh, I got it wrong. Okay. Blank on top, but then it's smiley face on the side. And the X here. Okay. So the 3 faces have folded together to make this. And we can actually see these 3 faces would fold, and these 2 lines would sort of be taped or glued together. But their appearance around this corner, which is going to be this corner, doesn't change. Okay? And so, you might say, all right, what's going on here? Well, these pieces here go smiley face. If we go sort of clockwise around the dot, we go smiley face, blank X. But here, if we go clockwise around the dot, we go smiley face X blank. So we wouldn't be folding things the right way. So we can just sort of leave it two-dimensional and still say, all right, clockwise around a dot, what's happening? And so now we know A is not the right answer. Let's try for something like B. So B has the V. So it's got the blank, the shaded piece. It's got the V going up, and then it's got this guy right here. Okay. So for this one, and do I have... I just realized my V is the wrong way around. V should be pointing down, almost like an A, but without the line there. Okay. So what could we say? Well, what's happening is we're actually meeting at this point here. And clockwise around this point, we go rectangle, V, and it'll be the shaded one. Well, we go rectangle, V, and the shaded one here, too. Does that mean B's the answer? Not necessarily. Because if, for example, the shape looked like this, it would be incorrect. But look what's happening again. Okay? At this point, okay, we can't tell anything about the shaded part, but part of the V is pointing up at this point. Well, in the picture, for B part of the V is pointing up at the point that we're sort of looking dead onto. And our rectangle is not pointed towards this point. Okay? And actually, everything sort of checks out. B is the answer. But, maybe we want a little more practice with our spatial reasoning, so let's see why C isn't the right answer. Okay. C is actually pretty easy to see why it's not the right answer. Okay, we're talking about this point that we're looking at head on. What point would that be at our net? Well, oops, we gotta shade that in, right? It's that one, yep. Okay, well, it would be... And then you sort of realize, wait a minute, how could the blank side and the shaded side, how could they meet together? They don't share an edge. So automatically you can say, oh, C's out. Okay, how about D? Why isn't D right? Yes, I know we found B in a real contest, you'd move on, but some people have some real trouble with three-dimensional problems. I know I do, so I'm trying to share how I sort of counteract that. And one of the ways to get better with three-dimensional geometry is to absorb all the three-dimensional geometry questions you can. Seek them out, try and find them, go ask math teachers. Do you know of any three-dimensional geometry, maybe net folding questions? Okay? Or when you're practicing and you're all done and you finish the contest because you want to practice it and try and do it as well as you can, come back and go to 13 and say, all right, let's really flesh this one out and let's really figure out, okay, why isn't D? Why must it be B? And things like that. So let's take a look at D. Okay, the video is allowed to run a little long. If you're not interested, I'm sure you'll skip to question 14. I'll see you there. But, so we'll get a little smiley face U here. And this guy here. And the X. Okay, now the X and the U, they do share an edge, but you'll notice that the U, the smiley face, and the V do not share an edge. They are opposite. They have one square in between them, just like the blank and the shaded side do. So that's why D isn't going to be the right answer. Okay, now let's do the last one, E. Why isn't E the right answer? So E is a little more like A in that it's not the sides that we need to pay attention to. It's not that there are two sides, it's not that there are two sides of the cube that could never meet. No. With E, you have shaded, smiley, and X, and these guys do meet. They do meet. All three of them are around this corner. So I know my diagram's getting a little scuffed up. So let's switch to blue. So this corner we found on the net. Okay. But again, you might go around and ask, all right, going clockwise around things, do things match up? And then if they do, then take the orientation of this smiley face into account. Okay, the smiley face is not pointed at this dot, but here it is. If we extended it, it might hit the dot. That's sort of what I mean. And so that tells me E is not the right answer. Okay, but on a clockwise level, we go X to U to shaded thing, and that is true. So you actually have to take the orientation of the smiley face into account. If the smiley face were pointed down and away, this would be a correct answer. But it's not, so E is also out. And that just further confirms B is the answer, which we worked out a while ago. Okay? But that's question 13, three-dimensional geometry, net folding. And, some of you out there are probably really great with these, but others, maybe like me, really still struggle with three-dimensional geometry. It's not something that's really done a whole lot, I find in high school. So it's one of the most common problems I see when I work with kids at our local enrichment program. That, three-dimensional geometry, things like this, not really emphasized. Okay, so that's question 13. Join me in the next video for question number 14, which, looking ahead, is a sequence-style question, not a three-dimensional geometry question. But if you're bad at sequences, you're going to want to watch that. So, maybe we can talk about sequences and you can pick something up. Okay? So, yeah, thanks for watching. Have a wonderful day.